Hi folks, this is number 17 on page 481, and this is actually a nice question. It's got a bit of meat on it. Okay, so what they give us here is two lines, and they tell us that this point A, so first of all notice these lines are parallel to each other, and they actually tell us that they're distinct. So we can assume that that's the case. We don't have to check that. But they tell us that the point A is on line 1, and they want us to find a point on line B such that AB is perpendicular to line 2. So again, best thing to do here is to draw a diagram. Okay, so we can really get a sense of what's going on. So if I call this L1 and I call this L2, so we know that they're parallel to each other. And we've got A, which is on L1, and we're looking for that point B on L2 such that the vector from A to B, okay, is perpendicular to L2. Now, as soon as you hear about a vector being perpendicular to another vector, hopefully you're thinking about the dot product being equal to 0. But of course, I can't take the dot product between a vector and a line, but I can take the dot product between a vector and another vector, namely the direction vector, which is parallel to L2. Okay, so I'm going to be working with this direction vector here, which of course is the same as line 1, 2, 1, negative 1. Okay, so I'm going to have to use the fact that this vector and this vector produce a dot product of 0. Okay, so this is my goal, is AB dot M is equal to 0, and hopefully I can use this relationship to determine what B is. Okay, so again, when we don't know a point, normally we just say, well, let's give it a name, X, Y, Z. Okay, but here, that's not much information because we're just going to be putting 3 variables into my equation. Okay, so while it's true that this can be represented by X, Y, Z, we actually have more information about the point B. We know that it's on line 2. Okay, so why don't we use the equation to be more precise as to what this point looks like? Because we know that any point on the line is going to look like, well, something like the right-hand side of this equation. So in other words, for a particular t value, the x component is given by 2 plus 2t. Okay, if we think of it in parametric form. Okay, the y component is going to look like 1 plus t. And then the z component is going to look like 2 minus t. And so what we have is we have a representation of this unknown point that has only one variable. And this is the trick to solving the problem. Okay, so the first thing we have to do is find the vector AB. Okay, because all this is representing the point B. So we just do that nice and easy by subtracting. Okay, so subtract the x component, so it's 2 plus 2t minus 5. So 2 minus 5 is negative 3. So negative 3 plus 2t. Okay, then subtract the y component, so 1 plus t minus 4. So 1 minus 4 is negative 3. Okay, plus t. And then here we have subtracting the z components, 2 minus negative 3. So it's 2 plus 3 is 5 minus t. Okay, so this is a representation of the vector AB, which I can now input into my equation. Okay, so we have negative 3 plus 2t, negative 3 plus t, 5 minus t. So this vector dotted with the direction vector, which is 2, 1, negative 1, has to be equal to 0. And in the end, I end up with an equation that has only one unknown, so we should be able to solve it. So let's do that here. So let's 2 times the x component, so that's negative 6 plus 4t. Okay, then 1 times the y component, so minus 3 plus t. And then here, negative 1 times the z component, so that's going to be minus 5 plus t, and that's got to be equal to 0. Okay, so let's, what do we have? We have 4, 5, 6. 6t equals negative 6 minus 3 is negative 9, minus 5 is negative 14. So bring the 14 to the other side. So 14, or negative 14 to the other side. So t is equal to 14 over 6, or 7 over 3. Okay, so what we just determined is the t value that's going to generate the point on line 2, which is going to have the property that we needed to have. That is that the vector AB is perpendicular to line 2. Okay, so let's just determine that here. So we have, okay, our point B, okay, is equal to, well, 2 plus 2t. So what I'm going to do is, since this is over 3, I'm just going to convert all these to fractions over 3. So that's going to be 6 over 3 plus 2 times 7 over 3. Okay, this is going to be 1 plus t, so 3 over 3 plus 7 over 3. And this is going to be 2, so 6 over 3 minus 7 over 3. Okay, and what do we have? We have 6 plus 14, so 20 over 3. Here we've got 3 plus 7 is 10 over 3. And here's 6 minus 7, negative 1 over 3. Okay, and there we have it. There's our point. Okay, so here, what the big trick to solving this problem, if we recap, is the idea that we had an unknown point on line 2, and instead of just calling it x, y, z, we actually use the form of the vector equation or parametric equation to write a more precise representation of that point. And then from there, we just use the fact that the dot product of perpendicular vectors is equal to 0. Okay, that's it for this one.